Section 1.4, pairs of angles. So looking at two angles and how they may or may not relate to each other. The first thing we look at is what we call complementary angles. And it's not complementary like, oh, you look really nice today. It's complementary in that they add up to 90 degrees. All right, so angles A, I know my alphabet, angles A and B, 53 and 37, you add those up, you get 90 degrees. We classify those as complementary angles. Supplementary angles. It's kind of the same concept. It's just that instead of adding up to 90, they add up to 180 degrees. Here's a way you can remember this. C in the alphabet comes before S. Numerically, 90 comes before 180. So C comes first, it pairs up with the 90. S comes second, it pairs up with the 180. Now these two angles, angle C and angle A, supplementary, add up to 180 degrees. Notice kind of how these three angles play off of each other. They're not exclusive. You know, angle A can be complementary to B at the same time. It can be supplementary to angle C. Now this is where we kind of get into a little more specifics and we need a bit of a checklist, okay? Adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior points. All right, so they are directly next to each other. They do not overlap. So right here, get two angles next to each other, call those 1 and 2. They have the common vertex with each other, right there. They have the common side right there, but they do not overlap, okay? I kind of think of it as, you know, when I was in college, I lived in apartments, and the kitchen of my apartment was not the bedroom of the apartment right next to me, okay? They were separate. They were right up next to each other. The walls were very thin, and you could hear everything that people were doing next door, whether you wanted to or not, but they did not technically, physically overlap with each other. And then we have a linear pair. All right, a linear pair is a special type of adjacent pair of angles where they are directly next to each other. They have the common vertex, they have the common side, but then their non-common sides are opposite rays. So they form a line pair, a linear pair. Special type of adjacent. So you can have angles that are not adjacent to each other. They're not next to each other. They overlap. Something's wrong with them. They don't fit this definition. But you can have adjacent and form a linear pair. They're adjacent. They're directly next to each other. And they form that line. So in the diagram down here, tell whether the angles are only adjacent and form a linear pair, or not adjacent. So if we look at angle, let's get some coloring in here. Angle 5 and angle 6. So angle 5 is right here. Angle 6 is right there. So, do they have a common vertex? Yes, they do. Point P. All right, so they're starting to fit our definition. Do they have a common side with each other? Do they each share a ray? Well, yes, they do. Ray, P, U. Now you have to look, okay, do they overlap? I don't know why I'd make that a Q. That's just wrong. And no, they don't. This 5 where I drew the arc, the blue arc, this 6 where I drew the green arc, they don't overlap with each other. So there's no overlap. And then do they form a line? Well, if I look, 5 goes from T to U, 6 goes from U to Q, from T all the way over to Q, we have that straight line. Yes. So all of this put together, all of these separate requirements, say that they are adjacent and a linear pair. Kind of going through it with that checklist. A common vertex, a common side, do they overlap, do they form a line? So take a minute to pause the video, look at angle 5 and angle SPOO, and then angle 7 and angle 8, and then check my online notes, see what results you get. So now some word problems. Again, in algebra, they gave you equations to solve. In geometry, you're going to have to write the equation that you need to solve. So an angle is 10 more than 3 times. Think about how to write that algebraically. Something is 10 more than 3 times. All right, so 10 more, that's plus 10. 3 times, that's 3x. All right, so an angle is 10 more than 3 times the measure of its complement. Find the measure of the complement. Well, you got to think, okay, what do we have to refer to as the complement? Well, we have all of this, plus 10, 3x, but it's all in terms of this x. So an angle is this guy right here. The complement is another x value. And because they are complementary, they add up to 90 degrees. Now from here, this is a pretty easy Algebra 1 equation to solve. 3x and x is 4x. Take the 10 away to get 80. We find that complement is 20 degrees. But it's all about picking apart the language and saying, okay, how do I create an algebraic equation out of this? When 2 lines intersect each other, we have angles that form on opposite sides, okay? And we call those vertical angles. They are 2 non-adjacent angles. So they're not adjacent, formed by 2 intersecting lines. So one of the ways that I usually break this down is I look at top, bottom, left and right. So they're on opposite sides of the intersection from each other. So top and bottom, that would be a pair of vertical angles. Angle 1 and 3, and then left and right, angles 2 and 4, that would be another pair of vertical angles.